I am happy to announce our first presenter, Maryna Kuzmenko, PhD, co-founder Petiole, and Maryna informed us that effective data collection helps to make better decisions and understand situations more clearly, especially in farming and forestry, which have suffered from the war. This process is crucial for studying how plants absorb heavy metal content from the soil. Dr. Maryna Kuzmenko will talk about two main studies. The first one look at how leafy vegetables take up heavy metals such as lead, cadmium, copper, nickel, chromium, cobalt, and zinc when grown with a special compost. The second one looks at how the cucumber plants take up arsenic and antimony and how this affect their growth. Lastly, you find out about a mobile app, Petiole Pro, exploited in both studies as it helps collect data easily and understand how plants take up metals, which is necessary for contamination monitoring in food and feed. We are very excited. So please, Maryna, we are ready to hear your presentation.
Thank you so much, Pavlo. And yeah, it's very nice announcement of my presentation. Thank you. And also I would like to say a huge thank you to Irina and Svetlana and to you, Pavlo, as I said, for organizing this conference. Particularly, we all understand that we as citizens and as Ukrainians, we are limited in what we can do exactly. For example, as scientists, we can do only what we can do in our niche. So that's why it's so important at least to focus on how we can work in the situation which we have now in Ukraine and what we have in the future. So yes, my presentation will be focused on the ways how to optimize data collection, and we will today we will speak a little bit about everything, but I understand that we are limited in time, and also I absolutely understand that it's much more interesting to have more live conversation and to answer questions. So we leave some time for that task. But meanwhile, also we will have discussion of this current situation with data collection and how it's the most popular ways how to do this, particularly for plant phenotyping and measuring plant traits. Also, as Pablo correctly mentioned, we will speak about two pre-selected case studies and why we have taken them out of the list, because both of them, in both studies, researchers use Petiole Pro for their findings. So you will see everything actually in the screen. And then we will not just show you the mobile application and the screenshots of it, but I hope our smartphone will help to demonstrate how to measure leaf area in a live mode. So we will do it immediately here and now. So let's start. And this is one of the images which are quite well known, and we all understand the devastating effect of war. And yes, all these 5 days, we are focusing on this aspect. And obviously, I don't want to repeat these all numbers because we have already heard many facts which are painful for us to hear, because we understand that all this contamination which we have because of military activities, they will go into soil, they will go into the food and feed, and that's why we need to think how to live and how to survive having this alongside to our lives and in every day of our life. So since research of contamination level and level of pollution is it's quite wide area of science, and there are different ways how the pollution and contamination elements come to the food and feed. but still there is the united moment of any of type of pollution. It's all about the methods how to detect this pollution. So it doesn't matter. Yeah, there are some still minor differences, but it actually doesn't matter too much. Is it this contamination because of the road, which is like highway with active traffic, or is this pollution because of some factory or plant? So still the crops and the plants, they are absorbing the heavy metals and other negative elements from the environment in the same manner as they are doing it from the military activities. And that's why we believe that Petiole Pro may be helpful for this type of work as well, for monitoring of the contamination which we have now in Ukraine. But what is the problem? And again, it's not only about Ukraine, it's all about the world, that there is a limited amount of methods and especially tools, how to get data, how to date numbers, how to get specific facts about that this is bigger, this is smaller. Obviously, most of the comparisons, especially if we are speaking about in-field research, when we are in the forest or somewhere else, far from, let's say, urban areas, it's quite difficult to have some handy tool which can help to get data and not just assess everything by eyes, because human eyes, they are quite limited in their ability to fairly and accurately assess specific size, color, or other plant trait features. And it's also the matter of question that the human ability and memory ability, visual memory, they are not so good in comparison with machines. And in comparison, let's say, with computer vision and with deep learning networks. So, for example, if we are working 8 hours in the same condition of greenhouse or in the same condition of forest, our eyes get used to the same level of greenness, let's say, and it means that at the beginning of working day, we have better abilities to judge what is larger, what is greener, than at the end of the day when it's 5 p.m. or 6 p.m. and you have already tired and it's not so easy to make fair decision or what's going on. And again, visual assessment, it makes life more problematic in terms of sharing this knowledge, sharing these facts and evidences, because yes, we all know that one person can be very good expert and they can assess properly, and even with after a long time, it can be after a long time of work in the field, they can work quite good. But I mean that it's still the work of one person, which can be, let's say, uploaded somewhere and then shared with the team who is sitting in the other city or in the other country. So that's why now we will go to the first case study which we have, and this is one of the first research papers which we had at Petiole Pro et al. So this research was published by two researchers, one of the University of Dahak from Iraq, and they were in collaboration with the lady from University from Germany, from the University of Hohenheim in Germany. And why it was the collaboration? So actually the Germany as a state, they funded the building of this municipal solid waste plant. So in fact, they were working on the improvement of the environment and decreasing the level of contamination because of the waste, especially solid waste. And they built this plant, this factory for processing of the solid waste. And as the result, one of the products which was developed by the product cycle of this waste plant was the compost. And this compost, it was used by farmers and by ordinary population to grow their food. And since the Germany were investing in this solid waste plant, they were trying to monitor the level of contamination which exists in this compost, which actually was produced by the plant, to understand, is it still healthy and is it still good to grow crops on using this compost. So this was the main objective, to track and monitor the level of contamination. And the researchers, they were checking six specific metalloids. It's lead, cadmium, copper, nickel, chromium, cobalt, and zinc. And actually, they have pre-selected 3 types of crops. It's leafy greens, and why leafy greens, I will explain in the next slide, because it was one of the findings which may be useful for Ukraine as well. But I mean that in this screen, you also see the screenshots which were published exactly in the research paper. So they demonstrated how they used Petiole Pro for measuring leaf area of this argola, as I see, and it was celery on the left-hand side and argola, as I see, on the right-hand side. But what was a good thing, and why they mentioned petiole also in their finding of the paper. So they mentioned that it was helpful for them to use Petiole Pro for this type of data collection, and they also recommended to use in similar types. And here I also put 2 more outcomes, which may be, as I said, useful for experience in Ukraine. It's all about the why leafy greens, because they mentioned that they did the research and they found that they were discovered that, for example, in radish, the largest amount of metalloids went to the upper side, so to the leaves. So that's why they focused on the leafy greens, since they are consumed by people directly. So and also one more finding which may be useful for Ukraine, it's about the soil type, and they find specific outcomes for clay soils. Yes, so this was published in 2019, and then I must say that Petiole Pro, it was mainly applied for plant health monitoring, and we rarely have cases for applying Petiole Pro for contamination, since this topic, it doesn't have a huge attention in the scientific audience. At the same time, we were curious that in 2020, there was another research, and this research was much deeper, because it was the PhD research made by one gentleman from the University of Liverpool in the United Kingdom, and he was trying to understand how the pollution of 2 specific metalloids, so it's antimony and arsenic, so how do they impact the growth and the development of cucumbers. And again, he put this screenshot into his research paper. Yeah, it's quite huge research paper. It's 450 pages, so it's in depth. It's very useful in terms if you need to think about some affordable methods, how to understand the level of metalloids in food produce, because he tried to create some new methods using affordable and available materials, because as he mentioned is his research that, and again, as we saw in this research in Germany, which I mentioned a few minutes ago, they mainly do all physical measures. They do in Iraq, but all the chemical measures, since they require some quite expensive equipment, they did it in Germany. So they send the samples to Germany and they process them. Regarding this study, so what he has done, he has already researched, he used physical traits and chemical analysis of the cucumber plants, and these are some findings which he discovered in his work. And yeah, so again, he mentioned our mobile application directly. So this was one of the proof for us that so that our work made some lives, some research more accurate and more data driven. At the same time, for example, in comparison with the previous research, the finding, one of the findings was that high metalloids levels were found in roots, not in the leaves. But for example, when we are speaking about leafy greens, it was focused on leaves. So it's again the ground for thinking, for thoughts, that if you will research specific crop, you need to do extra discoveries and extra research work on what is the overall situation. And because for some crops, it's the absorbance of metalloids is different. Yes, and then we can now speak about Petiole Pro in more details. And so what is Petiole Pro? At that moment when we of publishing these research papers which I mentioned, Petiole Pro was the tool for leaf area measurement. But since then, we have also created one more tool, which is helpful for plant health assessment. And this is, we are assessing the nitrogen status of plants. So let's say greenness, which is traditionally currently is measured by spud. But let's start with the leaf area. So leaf area, you can measure it in, we have two options. We have option to measure it with photo and with a live mode, but we try to invite people to use photo mode more, because it's all about the accuracy of algorithm, and it's all about the possibility for further work with the same samples taken. And we also focus on this way that it's in the field sometimes, yes, it's maybe working solution to have live measurements, because we had this experience of many customers are doing field research using live measurements and Petiole Pro. But as of now, we see that more people and more researchers are using photo-based methods, and we are inputting all our efforts to make and polish these methods of photo-based leaf area measurement. And you can see this leaf area measurement on the on the right-hand side of the screen. And on the left-hand side of the screen, this is the second module which I mentioned shortly. It's called DGCI. So if you will look closer to this a green button in the screen, it calls DGCIs. DGCI actually it's abbreviation of dark green color index. So this index is relevant to index which you have if you are applying SPUD, because again SPUD is working in the same manner. So SPUD is not providing you with with the level of chlorophyll, they just demonstrate the level of index in specific spot. And the same we are doing here in petiole, because we are providing the level of greenness in specific square. If you will see at the end of the leaf, there is a tiny mini square, white square. This means that DGCI, so the level of greenness, was measured specifically for that area. And yes, as with SPOD, the same with our DGCI measurement. It's not about the chlorophyll content of the plant. It's all about the chlorophyll content of specific area. And that's why if you will take a few samples in the same leaf, you will get different measurements, but then you obviously can make the average. So it will be some medium of your measurements. And yes, finally, what I want to say regarding DGCI, that DGCI, it's not our innovation. DGCI was developed 10 years ago, maybe even not 13, already 13 years ago, by the researchers of University of Arkansas. And they have created this index because they needed to monitor the level of nitrogen for corn. And yes, for corn, it's very, actually DGCI can be applied for different crops, but corn was the main initial crop where DGCI was applied. And since then, at that moment, the devices and the digital cameras were not so advanced. So, and access to digital tools was limited. At the same time, since now everyone has the smartphone in the pocket and they have access to get digital image of the leaf or any other part of the plant very easily. So it's it was our idea, why not to give this ability to use DGCI on everyday level, and you don't need to make any extra photos. You can make this one photo and you can get both measurements for leaf area and level of greenness, DGCI index. So I think now we will have no, not yet, not live demonstration. It will be after this slide, because this is the slide of our happiness and pride. This is a brief information about the benefits of Petiole Pro. So yes, firstly, and why it was created. It was created to save real people time. So we have friends who are doing plants research, and we try to help them to be more effective and to get more data in the same amount of time, and not use grid paper and not use simple scanner to get a leaf area, but use more advanced technologies, computer vision technologies, to get the leaf area. And since then, we already got 78 research papers, which were published in various journals and research resources, and they are published by the scientists from more than 30 countries. So it's quite a good map for us, that we know that many people from all the continents of the globe are using our mobile application. And also we are happy about the accuracy of our measurements, because, and by the way, you can always check the accuracy of the measurements with your tools, but we already have the research published by Turkish scientists, and they were comparing the accuracy of Petiole Pro and the handheld scanner Licor. And also we have done this research by ourselves. So we compared the ImageJ measurements with Petiole Pro, and yeah, we have the same numbers. So it was quite good for us. And yes, and we did the same with grid paper. So we try to verify the accuracy in different way, and we are glad that we did it. But yes, I think this is definitely the final moment for my presentation as of now. And now we will move into the the smartphone. So, and yes, I put this this screen to the for the people who will not watch us in a live mode, and maybe they will not have access to this video, so they can always check the presentation and go to our YouTube channel. We have regularly recorded webinars and different educational videos on how to use Petiole and how to get the better accuracy from Petiole. So now I will show you how to use it in, I will share my screen here with everyone. So I will continue, but I will show you also what are the tools we are using. So mobile application, it's in our mobile phone. So here we have it, but also I have this, sorry, give me a second, just my throat. Yeah, so also I have the calibrating pad, and this is very important part of the measurements because it helps to be assured that the accuracy of the measurement are fine. Also, I have the leaf, the simple leaf of tomato. In this video, I also used the tomato leaf since it was one of the available for me at this moment, and I can cut them freshly. So what are we doing for Petiole? If you have installed your mobile application, you opened it. Yes, you will log in using your email. You will open it and you will see exactly the same screen as you see now. And then you will have access to this the part which called calibration pads. This means that you can get your calibration pad by yourself by printing it. So you just need to DIY and go to the list of calibrating pads. Actually, we have this list of all calibrating pads since 2017. It's our very first version of Petiole. At the same time, you need to find the calibration pad which looks like this. So we have a few of them here, so you can print it out, download it and print it out in your simple printer, your ordinary printer. At the same time, I must say that for leaf greenness, you will not have these green markers because we produce them individually, and these calibrating pads are handmade. So we actually provide them per request, so on the individual basis, as I said. But for leaf area and for all these case studies which I mentioned, they use only leaf area. You can use the calibrating pad, for example, here. Sorry, not this one. Yes, for example, here you are opening it and you are printing it in simple paper. We don't recommend to laminate because sometimes it creates some glare and some inaccuracies. At the same time, you can, as for example, we put it into the acrylic basis and it makes better use of the calibrating pad. So let's imagine that you already have your calibrating pad. And then what you need to do, you need to place your leaf on the calibrating pad, and then you need to make a photo of your leaf on the calibrating pad. So give me a second, we will do it now and see what will happen. Yes, so with this leaf, it's absolutely fine. This leaf is not big, so we will do like this, and also just in case, because I see some shade from the window, so this may create some inaccuracies. So it's always nice to have twice. But also what I wanted to say that this leaf is quite small and it doesn't cover the markers, which are these black squares. But sometimes the leaves are big and wide, so you need to be to double check twice that your leaf is not covered any of these markers because the accuracy will be injured, let's say. It will be not so accurate as we think. And I can show you with this with, let's say, let's cover one of the markers and make a photo as well. And we will compare what we will have then. So now we made our photos. They are perfectly fine. So here we have our photos. And now we go back to the Petiole Pro, and we are starting to use photo. Yes, and in Petiole you can use not just photo from memory of your phone. You can also use the photos from, let's say, Google Drive or any external memory place. Okay, so let's have this photo which we have taken. Yeah, so what we have now, we have, sorry, give me a second again. It's morning. So what we have now, we have the leaf, which is the segmented from the background. And if we will touch the leaf, we will see, and scroll down. So we will see the capture of leaf, and it's not absolutely accurate, let's say, because you see this white pieces of background which were captured. At the same time, so we can save this measurement. Yes, let's save it. At the same time, we have the other segmentation algorithm. So we press another button, and here again we press on the leaf. Yes, here you see we press on the leaf, and we see that the area is different, and the accuracy of background cutting, the segmentation is better. So that's why we also save this measurement. You see, we have less white areas. There is still small shady areas which was captured, but it's also related with the light. So if you will do appropriate light, don't do please in the sunlight, and there should not be any direct light on the leaf, because it will be it will create extra shades and it will bring some inaccuracies. But if you will do the measurement and photos in your own shade, then it's quite good working practical tip how to avoid any shades. But let's go back to our tomato leaf. So as we saw in segmentation 1, we had 1391, but it was with extra space. And in this we have 13 square centimeters and 13.14 square centimeters. So this is the demonstration how you can select the best working solution for you, and where can you get the measurements which you saved. So you are going back to your home screen, and here we have, so this is the leaf area number 1, and you can copy it, and then you can send it anywhere or share with other people, or you press next and just have the same leaf from the first segmentation, which was not absolutely accurate. What we can do again with this leaf, if you have these green markers which I mentioned, you can also measure the level of greenness. So the same photo, the same leaf. Here we have our leaf, and just touch it somewhere where you will be, where you are interested. And you see that in our case, the leaf is mainly, I have the same level of chlorophyll in different points, but let's see visually, maybe there are some other places. For example, here you see the DGCI level is different. So we can save all the measurements. We can save the measurement. And one more aspect which I want to mention, that you can also go here and just see the capture of this specific white square, which you have measured the leaf greenness over there. And again, you can go to the home, and find your measurements here. Yes, and I also wanted to show you that the accuracy of if one of the markers is covered, that accuracy is not good. So let's go, because I see that we are going very close to the end of the session and the end of my presentation, so I need to be faster. So this is the photo which we captured, and as you remember, we covered the area here. So as you see, the area is still captured, so you can still see the leaf, but it's 14, and you see the inaccuracies are big, quite substantial, we can see that. And let's see the segmentation number 2. It even it can't understand that this leaf is the leaf and the object which must be checked. So in this case, we even can't. Yeah, we found something. Sorry. Yes, we found, but you see still the quality of segmentation is not as good as when all 8 markers are visible. And just a quick, I will also save it just in case. And yeah, so in this webinar, which I mentioned in my screen, we have more in-depth demonstration of different cases, how to apply Petiole Pro for variety of leaves. If you have, let's say, rice leaf or some other narrow leaves, you can place a few of them in the same screen. But I want to show you one more tool, how you can understand the accuracy of your measurement. So let's say you did the measurement and then you can't understand why it seems like the leaf is not captured. You always can check, are all the 8 markers in photo or not? So this you can press here, vision calibration, and here you see these markers are visible, but 1 is not. And 7 means that the camera have captured 7 markers, and it's not correct. This means that you can expect some problems. But for example, if we are doing the same, here is our vision calibration, and we are doing with this leaf, which was captured properly, you see the number 8. So this means that camera was working properly and captured 8 markers, and this was the good outcome of what you can do. And yes, one more positive moment, as I said, about Petiole and possibility to use photo-based measurement, that you can share it with everyone. So you can share this. I can show you that we have, as I said, in Google Drive, we have made a few, where is it? Sorry, I can't find it, but I mean that we have made a few captures from different places, from different researchers, and we still can go back to them. But for example, if you're doing live measurements, it may be convenient with huge amount of leaves, but it's not working for sharing the history of research and for sharing this with other people. Okay, so let's stop with this live demonstration as of now and go to the, oh, sorry, no, it should not be. I don't want to demonstrate you this. I want to continue a little bit with presentation. Yes, because, oh, sorry. Sorry.
Thank you so much for joining us.
Yeah, this is our webinar, but we'll go back to our presentation because it's actually almost the final slide. It's the brief result of what have I showed you and told you in the last 40 minutes. So I hope you see some value in Petiole Pro, and yes, it's just one of the parameters, and we understand that for proper analysis of bio-uptake of metalloids by plants, you need to have wider analysis, and you need to use as many data resources as possible and methods as possible. At the same time, this is the physical method measurement, and it can help you to get real data and at least to compare what can be compare more accurately what you can demonstrate. And one interesting moment that yesterday at the conference, there was a presentation of Vital preparation. And that's interesting because we have research paper which was published a few years ago by Ukrainian scientists. So they applied Vital, as I remember, for corn. And they used Petiole Pro for leaf area measurement, and they rely on data captured with Petiole Pro to prove that Vital was a good biostimulant for growing crops. So this is how we are interlinked with other speakers at the conference. Yes. And this is my huge thank you for your time and for your attention. And I still believe that we have a few minutes for questions, but as you see, there is my email. And if you have any questions, I am always happy to answer them via email. We can schedule a call and I will do my best to help you with your specific type of research or your work which you need to done. And if Petiole Pro can help, I will be glad to help as well. So are there any questions?
Thank you very much, Maryna, for your work, for your wonderful presentation. And I think that apart from application by academic researchers, this could be definitely used also by farmers and by citizen researchers, at least for initial assessment of the state of art. And if they expect some problems, of course, they could do more laboratory analysis. So we indeed have questions. One is which SPAD parameters are most recommended for monitoring of individual heavy metals? I mean, this is complex question, so I will read you first, but then I can repeat just part by part. How do you determine background of use SPAD-based machine for heavy metal analysis? Do you able to develop some hyperspectral indexes or parameters?
Okay, Pablo, thank you for the question. But the only issue is that we are not focusing on SPAD. And I was mentioning SPAD as the comparison of alternative for DGCI, because the problem of SPAD is the cost. And if you will decide to use SPAD in your research, and we meet this problem everywhere, so even quite advanced level research organizations, they have SPADs in limited quantity because the cost of SPAD is quite high. And the problem is that researchers are allowed to use SPAD not on daily basis, but only, let's say, today, and then in 3 weeks, they are in a queue to use SPAD. But this provides, that doesn't show the full picture of what's going on with the plant, because plant is a live organism and it changes all the time. So, and especially with different environmental conditions. So that's why I was speaking about DGCI and leaf greenness tool, because it's the alternative for SPAD, which is affordable and available, and it doesn't cost that thousands of dollars for one item. And again, we have research papers which were published by, so we have regarding the DGCI index, we have 4 research papers focused only on DGCI, and they mention directly that a leaf greenness tool is one of the alternative methods how to get the greenness of canopy, understanding the greenness of canopy using some affordable methods. So probably the answer to the question will be that there is some research based on SPAD and their abilities to apply SPAD for different environmental conditions, and especially in comparison with hyperspectral imagery. But for my purpose today was to demonstrate the available, affordable, and scalable tools, because SPAD is not scalable at all. You can't share the SPAD with the team of 20 people. But when it's all about mobile application, you can download it and use it simultaneously and measure the greenness using the same tool by all your team.
Thank you very much, Maryna.